One second. Okay. We will start. So have I given you assignment for KNN? Have I given you assignment for KNN?
I don't think so, ma'am.
No,
Huh?
ma'am. No, ma'am.
It's not given. One second then. Okay, I will send the assignment for KNN also after the class. Okay, so last class we have seen regarding our vector space classification, right? So vector space classification we have seen in our last class, and also we have done Rocio's classification, KNN classification. So this classification we have done, and for SVM I have sent already given you this material for SVM that you can just go through by yourselves. Materials I have already sent. So today I have sent, you can check it after the class. So we will start a new topic today. And assignment also I will send for KNN. Okay, KNN assignment I think yet to send. For OQs I think I have sent. For OQ classification, did I send you the assignment for OQ's classification?
Ma'am, the most recent assignment that we got is for Bernoulli's.
Bernoulli's and
Language modeling.
okay, let me just check. So many of you are not submitting your assignment. Okay, so try to submit before this month, because your assignment internal calculation will be done before this month. Okay, so midterm and internal I have to do the mark entry before this month, April month. So please you try to submit your assignments before 30th of April. Otherwise, your internals won't be counting. Okay, so last assignment I sent was regarding your Unigram language model and this one, no? Advanced merging query livelihood model. Okay, so today I will send you assignment on Bayes classification. Did I send assignment on Bayes classification? Yes, Bayes classification and Bernoulli's I
Yes,
have
ma'am. Yes,
sent.
ma'am.
Rocchio's
Yes, ma'am.
classification I didn't send, right?
No,
So
ma'am.
this Rocchio's classification, what you have to do is, yeah, this is almost similar with Bayes classification. So additional, you need to find out DF, IDF, that thing. That's so I'm not giving assignment on Rocchio's classification. Instead, I'm giving assignment on KNN classification. Okay, so KNN, for this one, you can solve using the first method, k equal to 1, and also you can solve the same with k equal to 3. Okay, so that I'm giving you now. Otherwise, chapter number 8, KNN assignment. So I will share now. Assignment KNN. Okay, so I have sent assignment for KNN. Now we will go to next chapter, cluster. We will go to clustering today. So clustering. So clustering, this will be your last chapter. Okay, clustering, which I'm going to teach you now. This will be your last chapter. So by this week or May first week, I'll try to complete your syllabus. So let me share the screen for clustering. So clustering, there are two types of clustering. So you already know what is clustering, right? So clustering, normally it will group similar objects. So when we say in terms of objects, clustering means we are going to group similar objects. So that concept we are going to use in text or documents. Same thing, but we are using in documents or text. So we will be grouping similar documents, or we will be grouping similar set of texts in our chapter. Okay. So clustering algorithm group a set of documents into subsets or cluster, and how they are going to group is documents within a cluster should be as similar as possible, and documents in one cluster should be as dissimilar as possible from other documents in other clusters. Okay, so in one cluster, if there are 3 documents, that 3 documents will be similar. And if there are another, say, suppose you have cluster 1, cluster 2. So let us just consider cluster 1 as class 1 and cluster 2 as class 2. So all those documents in cluster 1 will be similar. And all those documents in cluster 2 will be similar. But comparing cluster 1 document and cluster 2 document, they will be dissimilar. That means it won't be similar. Okay, so that concept we are using here. And as we know, cluster is just group of similar objects. So we have two types, flat clustering and hierarchical clustering. So flat clustering, this creates a flat set of clusters without any explicit structure that would relate clusters to each other. So we will see how many types of flat clustering are there and how many types of hierarchical clustering are there. So clustering normally use the concept of unsupervised learning, whereas in classification, we use the concept of supervised learning. So you know supervised and unsupervised already. Supervised learning in the sense where the classes are labeled, already given, already known to us. And in unsupervised learning, the classes are not labeled. That means the classes are not known to us. Okay. So we will see what is classification here. So classification here also they will be defined, and classes are human defined. Okay, the classes are human defined. That means the classes are known to us already and part of the input to the learning algorithm. So this will be used as an input to our learning algorithm. Whereas in clustering, these are not human defined. Okay, these are not human defined. Based on some properties, based on some calculation, we are going to label the classes. That means the classes or the properties are initially not known to us. Then one second. So we'll see the types. Types for clustering. So flat algorithm and hierarchical algorithm, as I told you, there are two types. So in flat algorithm, for example, you have heard about k-means algorithm, right? So those k-means algorithm that comes under flat algorithm, because they usually they are starting with a random partitioning, or we call as partial partitioning. Okay. So random partitioning or partial partitioning of the classes into, of the objects into, or of the documents into groups. Okay, that is this one, flat algorithm. Okay, so flat algorithm, once again, let me tell you, flat algorithm, it starts with some random partitioning of documents into groups. Whereas in hierarchical algorithm, we start with a hierarchy. We start with a hierarchy. And you can see second point is, for flat algorithm, we refine iteratively. Okay, for flat algorithm, we refine it iteratively, whereas in hierarchical algorithm, we have two approaches. One is bottom-up approach and one is top-down approach. So bottom-up approach, it is known as agglomerative, and top-down approach, it is known as divisive algorithm. Okay. So these two, again, we will see these tools. We are going to focus in what is that? Agglomerative and divisive algorithm. So we are going to focus on this one. Okay. This is about k-means algorithm. One second before that. Hierarchical. This one. Okay, so let us see agglomerative clustering and divisive clustering. So we will also see k-means algorithm, but first we will see agglomerative clustering and divisive clustering. So as I told you, agglomerative clustering, it is the bottom-up approach, and divisive clustering, it is the top-down approach. So each observation in agglomerative clustering, they are starting with each own cluster, and they are going to pair up as the cluster moves up the hierarchy, or as the data points move up the hierarchy. So in agglomerative, so every single element will be at the bottom line, and they will be grouped according to the similarity between objects. So individual data objects will be considered as a single cluster. Okay, each data objects will be considered as a single cluster. So at the bottom line, suppose if we have five data points, the A, B, C, D, E. So we have 5 data points A, data point B, data point C, data point D, data point will be considered as a single cluster. So we consider A as a single cluster, B as an individual cluster, C as an individual cluster, D as an individual cluster, and E as an individual cluster. So now what we are going to do is we are going to check the distance between A cluster and B cluster. Then A cluster and B cluster. Then find the distance between A cluster and E cluster. So from A, we are going to find the respective distances between the clusters. Okay, we are taking A as the origin. So A and B, find the distance. A and C, find the distance. A and D, find the distance. A and E, find the distance. And after that, we will get a minimum distance value. So that minimum distance value we are going to group together. Suppose when you find A and B, A and C, A and D, A and E, if you find A and D has the minimum distance, then you are going to group A and B together. Okay. Similarly, after grouping A and D, next minimum distance they are going to group like this. So step by step, we are going to group until we get a single cluster. Until we get a single cluster. So that process is known as agglomerative clustering. And the same process will be done for top-down clustering also. So we will see the algorithm. So assigns each observation to its own cluster first step. Okay, so we are considering the individual data points as each own cluster. That means as individual clusters. Then after computing the similarity, that means we are going to compute the distance between the clusters and join the most similar objects. That means the minimum distance objects will be grouped together into one cluster. So this process will be repeated until there is a single cluster left. So you will see this one. Okay, so you consider A, B, C, D, E, F. We have 6 clusters here. So initially, each A, B, C, D, E, F are the data points. Then this will be considered as a single cluster. Then you find the distance. A and B, A and C, A and D like this. Then B and C, B and D, B and E, B and F like this. Do you find the distance? So that the distance value will be given. Okay. But for this example, the distance value is not given. Just for your understanding purpose, a demonstration is given without the data points. So this means that B, C, D, E, F, they have the minimum distance A. So this B, C, D, E, F, they are grouped together here. So, and again, after B, C, D, E, F, we are finding the distances among them also, and we are grouping here. B and C again has the minimum distance, then D, E, F, these 3 individual data points has the minimum distance, and finally, along with A, it is being grouped into a single cluster. So this practice we are going to do until we get a single cluster. So that is bottom up. It starts, so this side you can see left side it is shown here bottom up. That means agglomerative clustering. And the same process if you do in vice versa, if you start from the single cluster and if you divide and until we get a individual cluster, that is top down, which means divisive clustering. So those two things you need to know. One is bottom up approach, one is top down approach. One starts with the individual clusters and one starts with the single cluster. In bottom up, it starts with the individual clusters until we form a single cluster, whereas in top down we start with a single cluster until we get individual clusters. So divisive clustering, as I told you, it is a top-down approach, and the algorithm you can see here, it assigns all the observations to a single cluster. So initially there will be a single cluster, and then we are going to partition the cluster into least similar cluster. That means until we get individual cluster. So this process will be repeatedly after being done on each cluster until there is one cluster for each observation. That means this is top down. So the same thing, only the same diagram, we have just drawn it into separate ways so that one shows the bottom up, the other shows the top down. This one, I think this is for K-means. No. Okay. Now let us see one more example for agglomerative and divisive. So we have these documents here. You can see here data points are given. So in this example, we don't have any data points values, so we don't know how to calculate, right? So it's just a demonstration to show, it's just a graph like a visual representation to show the bottom up approach and top down approach. Now we will see this in using the data points. So we have documents. So as I told you, our clustering will be based on our documents. So we are going to find the distances and all, right? So using example using distance matrix. So we distances from 3 clusters. So that means we have document D1, we have document D2, we have document D3, D4, D5, D6, up to D10 we have, okay. We have 10 documents. Then distances from 3 clusters. So we are going to find the distance D2, D5 and D7. So before this, I think I need one more table. This is directly after the calculation of the distances. Okay, anyway, let us just go through this and I will show you another example. The same example, but how these distances are being calculated. So anyway, D2, D5, D7. So we have 3 clusters, distances from 3 clusters. That clusters are D2 S1 cluster, D5 S1 cluster, and D7 S1 cluster. Okay, so that we are finding the distance D1 and D2. Okay, we are finding the distance D1 and D2. The value is 2.0. D1 and D5, the value is 2.6. D1 and D7, the value is 2.2. Like this, D2 and D2 is 0. D2 and D5, D2 and D7. So we are finding all the distances. Then we find the minimum distance. So from this 3, which one has the minimum distance? We have 2.0 as the minimum distance. Then in this second row, 0, 2.6, 1.7. Which one has the minimum distance? 0 has the minimum distance. So among these three distances, which one has the minimum distance? In the third row, 2.2 has the minimum distance. Then in the fourth row, 2.6 has the minimum distance. So we have written down all the minimum distances here, and we are going to do a movement process. We are going to do a movement process, means D1, we are going to move to the minimum distance cluster. So in this, which one has the minimum distance? 2.0 has the minimum distance. 2.0 is nothing but our D2. Okay, our D2. So our D1 will be moved to D2 cluster. Okay, so our D1 is moved to D2 cluster. D1, you can see the first row, D1, so this D1 is moved to D2. This moved to D2. Okay. Now, for D2 also, which one has the minimum distance? It is 0. So for D2, no need to move because it is already the same cluster. Let us see for D3. So for D3, the minimum distance is 2.2. 2.2, which means it is D7 cluster. So our D3 will be moved to D7 cluster. Similarly, for D4, which one has the minimum distance? 2.6. 2.6 belongs to D7. So 2.6 belongs to D7. So our D4 also will be moved to D7 cluster. So D5, it is already the same cluster, so no need to move. For D7, the minimum distance is 2.4. 2.4 is nothing but our D2 value. So D6 will be moved to D2 cluster. Then D7, it is already the same cluster, so no need to move. And now D8, which one has the minimum distance? 2.0 has the minimum distance. 2.0 is nothing but our D5 cluster. So D8 will be moved to D5 cluster. And it goes on D9 and D10. For D9 also, 2.0 is the minimum cluster, minimum distance. So 2.0 is nothing but our D2 cluster. So D9 will be moved to D2 cluster. Same way for D10, 2.2 has the minimum distance. 2.2 belongs to our D2 cluster. So D10 also will be moved to D2 cluster. Then after this, so I have all the D1, D2, D3, all the documents in one cluster. All the documents in one cluster. Now, since according to the similarity, according to the distance, we are going to move down. So that means you can see here, you can see the distances from here. So D1, D2, D6, D9, and D10. D1, D2, D1, D2, D6, D9, and D10. Okay, so all this belongs to D2 cluster, right? Because D8 is D9 is also assigned to D2. D10 is also assigned to D2 because of the minimum distance. D6 also assigned to D2 because of the minimum distance, and D1 also assigned to D2. So D1, D2, D6, D9, and D10, since they have the they belong to D2 cluster, all of the cluster documents belongs to D2 cluster. We are grouped, these documents are grouped together in one cluster. Then D5 and D8, you see here, D5, it is already D5. So D8 is moved to D5 because they have the similar distance value. So D5 and D8 into one cluster. So remaining documents you see here, D3, D4, and D7. D3 also moved to D7, D4 also moved to D7, and the D7, that same cluster. So these three documents in one cluster, D3, D4, D7. And after that, individual, this will be partitioned into individual single clusters. Individual single clusters. So this starting from the single cluster and moving down until we get individual uh, documents or individual data points. That is top down. Okay, if you start from this single clusters, that means if you start your observation from the partitioning from the top of the data, and otherwise vice versa for this one, bottom up, in the sense you have to start with the documents at the bottom line. Okay, I have D1, D2, D3, D4, D up to D10. Then after finding the distance, I find these four distances similar and I group into one cluster. So like this. Okay, D1, D2, D6, D9 and D10 into one cluster. So now I find distance for D5 and D8 becomes similar. So these two we group into one cluster, D5 and D8. Similarly for D3, D4, D7, they belong to one cluster. So I group like this and becomes a one cluster. So all these three again, I group together and it becomes a final big single cluster. So if you start like that from bottom, then it is agglomerative clustering. And if you start from this top of the this clustering, this one, no, partitioning, if you start from this top element, then that becomes a top-down clustering. Okay, and let us see how these distances are calculated. So nothing but some data points will be assigned to its value, then we will be finding the distances. But anyway, let us see. So from this only, the distance matrices are calculated, okay, using Euclidean's distance. So from this only, this is the for k-means clustering. So after k-means clustering, we can also derive this one, drawing the agglomerative and top-down clustering we can derive. So let us see this one, k-means clustering versus the flat clustering. So we have 10 documents. Let us see the example directly. The first one is term frequency matrix. So this is frequency matrix, okay, not the binary matrix, it is the frequency matrix. And you can see here D1, D2. So the frequency for online, I'm not giving the complete data, but just the table by counting the frequency. You can see here it shows how many times one word has appeared in the document. That means the frequency of the term. For example, in document 1, in D1 shows the words online, book, Delhi have each been mentioned once. So their frequency will be 1. So for D1, you can see here D1, online 1, book 1, Delhi 1. That means online, book, Delhi occurred one time. Okay, so they occur one time in the collection. So their frequency is 1, 1 and 1. Similarly, in document D2, we will see the occurrence of the online, book. They have occurred two times, whereas festival, flight, Delhi occurred one time. So in document D2, we have written in online 2, festival 1, book 2, flight 1 and Delhi 1. In the document 3 collection, so in D3, for example, in D3, book occurs one time, flight occurs one time, Delhi occurs one time. So 1, 1, 1. Online is not occurred, so it is represented by 0. Festival is not occurred, it is represented by 0. Now in D4 also, online occurs 3 times. Online occurs 3 times. Festival occurs 1 time. Book occur 0 times, because it is the particular term book is not occurred in the document D5. For flight, it is not occurred. For Delhi, it is not occurred. So like this, up to D10, I have a document frequency table, term frequency table. Okay, term frequency table, which means you have to count the number of times this particular term occurs in the document. So after counting that one, let us assume we want to create 3 clusters. Let us assume we want to create 3 clusters. So let us randomly take. Then randomly let us choose 3 clusters. So I am choosing D2, D5 and D7 as the initial seeds or initial clusters. So randomly I am choosing D5, D2, D5 and D7 being chosen as their initial clusters. And after that, what's the next step? Next step is to find the Euclidean distance. Euclidean distance from D2, D5 and D7. So for each document, we are going to find the distance from D2, D5 and D7. So that is what Euclidean distance, D document D, X and Y. X is nothing but, X and Y are nothing but, suppose if you want to take first calculate the distance D1 with the first cluster. So first cluster is D2. So distance of D1 and D2. Distance of D1 and D2. Okay, the values are not seen here. Okay, the values are not seen here. So let me share another. Yeah, I'll close this screen and I will share you another screen. The same screen but with the calculation values. Here they have just said the dxy and the calculation, the formula is not seen here, and the distance calculation is also not seen here. Okay, so I will close this and we'll share the calculation one. Yes. Yeah, I hope you. One second. Yes, okay. So the same example calculation I will show you. So Euclidean distance, this is the formula which you have to use to find the distances from the documents D1 and D2. Okay, D1 and D5, D1 and D7. Like this we are going to find, because we have initially chosen there are 3 initial clusters. So from the remaining documents D1, D3, D4, D6, D8, D9 and D10, we are going to find the distance comparing with the clusters chosen. So first, let us find D1 and D2. Let us find D1 and D2. So D1, the value is 1 here, the frequency is 1. D2, the frequency is 2. So that value I have substituted here, the first value 1 and 2. Like this, for the second term 0 and 1. For the third term 1 and 2. For the fourth term 0 and 1. For the last term Delhi 1 and 1. So all these frequency values are substituted here. Okay. Then after doing the Euclidean distance, I got square root of 4, which the distance is 2. The distance is 2. So that 2 I have written here. So this is the table which we have seen just now for constructing the agglomerative and divisive table, divisive clustering diagram. So for D1 and D2, this is the documents D1 and D2. D1 and D2, the distance is 2. Like this, you have to find all the distances. Now, next step is you have to find D1 and D3. That means D1, all these values in the first row and all these values in the third row, you have to find the Euclidean distance. Similarly, D1 and along with the clusters only you have to find. So for D1 we have calculated. Now D3 and D2. Okay, D3 and D2, then D4 and D2, D5 and D5. This is the cluster, so no need to find. D6 along with D7 and D7, this is the cluster. So D8, D9 and D10 with respective 3 clusters. So that calculation I will show you here. Okay. So D1 and D2, D1 and D5, D1 and D7, because these are the 3 clusters which we have selected as the initial seed. So these 3 clusters is the main clusters which we will be computing the distance with the remaining documents here. Then D2, then D3 with these 3 clusters, D4 with these 3 clusters, D5 with these 3 clusters, D6 with these 3, then D7 with these 3, D8 like this. Okay, and this calculation is based on this table. That means document term frequency table. Okay, so finding the distance, as I told you, you have to find the minimum distance. And you have to do a movement process. Movement process is just to group the clusters. So D1 we have grouped to D2 based on the minimum distance, because for D1 and D2 the distance is 2, D1 and D5 the distance is 2.6, D1 and D7 the distance is 2.2. Which one has the minimum distance? D1 and D2. So this D2, D5, D7, they are already selected as the initial seed clusters. So D1 will be moved to the minimum distance cluster. So D2 has the minimum distance. So we move D1 to D2. So that's why it's written here in the movement part D2. Similarly, D3, this is the initial cluster, so no need to move. So D3 minimum distance is 2.2. 2.2 belongs to D7. So D3 is moved to D7. Okay, the same process. And after that, in D2, how many number of observations are there, or how many number of documents are there? 1, 2, 3, 4, along with D2 itself, 5. So there are 5 observations or 5 documents. And D5, how many documents are there? D8 is moved into D5. So along with this D5, it is 2 clusters or 2 documents. And in D7, how many documents are there? D3 and D4, and along with D7 itself, there are 3 number of clusters or 3 number of observations are there. Okay. So all explanations are given here also, along with the distances value, how the distance, how the document is moved to the clusters. So that thing, the explanation is given here. Okay, I have done the explanation also. In case if you don't understand, you can just see the explanations given here too. Okay. So the 10 documents we have moved into 3 different clusters. Okay. And further calculations we can do by calculating the centroids and all. So this is not that much important because it's going somewhat little extra thing which I have added, because for k-means normally we need to calculate the centroid. Centroid calculation we have already done, right? In our last chapter, we have done the centroid calculation. So from the same table, we can do the same process like how we do in the Rocchio's classification, because in Rocchio's we have done the centroid calculation. So that thing we can put up here. So it will be same process. That's why I didn't put the calculation here. Okay. So K-means algorithm with centroids. So that means you have to do the calculation right from here. Right from here, you can do the calculation. You can find out the centroids. And after finding the centroids, so these are the steps. We have to choose the K number of clusters like how we choose here. Okay. K3 we have choose here randomly, and considering those 3 clusters as the initial 3 seeds. So D2, D5 and D7. The same process, it is written again here. Then assign each object to their closest cluster. How? By finding the Euclidean distance. So from this table, find the Euclidean distance and you assign. Assignment is this part. Okay. How to assign. Finding the minimum distance and moving the particular document to the nearest distance cluster. So since D1 has a minimum distance with D2, D1 is moved to D2. That is what this statements. Okay. Then we need to find the mean points here. After finding the mean point, that means the average. After finding the average, if there are no changes, then we will finish with the 3 clusters which you have assigned initially. And otherwise, if any changes is there, then we can repeat the same process again. We can repeat the same process again. How? By finding the K value. K clusters, randomly assigned clusters. We can randomly assign some different documents as the cluster, then repeat the centroid calculation, then assignment of each object to the closest cluster. So this process can be repeated until there are no changes on the cluster centers. Okay, if there are no changes. So after computing it again, and if you find the same observation like this, then no need to calculate next one more iteration. You don't need to do the iteration. You can finish with the first iteration. So like this, until we get the same number of clusters, we can find. So it's an iterative process. Okay, that is K-means algorithm. Diagrammatically, we have explained here selection of the initial clusters, assignment of the documents by finding the distance, and then finally moving to the movement of the centroids. So this is about your K-means algorithm. So the same table, this same table I have used for drawing the agglomerative and divisive clustering also. Okay, so the same table can be used for constructing the agglomerative and divisive clustering, which I have just shown in your PDF now. Okay, so these materials also will be sent to you. Okay. So clustering, I think there are very less chapters and very less topics in clustering. I think one more is there or not. Let me check. Yeah, one more example we can see in our next class. Okay, so for today, that's all. That is your clustering, agglomerative clustering. We have 2 types. One is flat clustering and one is the hierarchical clustering. So clustering, as you know, it is grouping of objects, similar objects into one cluster, or we can say moving of your similar documents into one cluster. So that is clustering. So in flat clustering, it is normally we consider a defined iterative process, and in hierarchical clustering we have agglomerative and divisive clustering. So for K-means is the example of flat clustering, and the example for hierarchical clustering is that top-down and bottom-up approach. So for K-means, you can see here the example I have explained just now. You can go through the example. So this is how we normally perform finding the document term frequency matrix, and after that finding the distance, then grouping into clusters. So that after grouping into cluster, what we can do is we can construct from this table, from this distance matrix table. By taking this distance matrix table, we can construct agglomerative clustering as well as divisive clustering. Okay, so those are important points for uh, clustering types. So I'll take a quick roll call. Roll number 1,
Present, ma'am.
roll number 2,
Present, ma'am.
roll number 3,